Hey guys, so I wanted to go over some of the notes that I have for our section 22A talking about the sun. These are a little different than the ones that I put in LMS for you because these are not the Bob Jones ones. So hopefully these have a little more detail and will help. I know you have a quiz today, so if you want to go over these before the quiz, that's fine. But the intro here to the sun that you hopefully have read about on your own and seen in the videos you've watched, the sun is actually an average star. It's a source of light and heat for us here on Earth, and it's also a signpost for seasons, days, and years. So it helps us determine when seasons start and the beginning and ending of our days and years. It has a diameter of 1.4 million kilometers, and that's 109 times the diameter of the Earth. And it's about 150 million kilometers away from us. Some of your questions on your quiz are going to be like they're going to give you a word or a phrase, and you're going to have to say if that relates to the sun's energy or the sun's activity or whatever. So make sure you pay attention to the headings when we go through these. But relating to the sun's energy, 93% of its energy is some form of light or electromagnetic waves. Now, that doesn't mean that we can see all of those, which we're going to talk about here, but these can be radio waves, visible light, or X-rays. The solar spectrum, this is the entire span of electromagnetic waves emitted by the sun. Okay, so this light energy is electromagnetic waves. All light has electrical and magnetic energies, which is why it's called electromagnetic waves. The wavelength, which there's a nice picture of this in your book, so if you're confused about it, make sure you look at it. We talked about this actually with our ocean chapter too, though, but a wavelength is the distance from the top of one wave to the top of the next wave. So measuring it in the same place from one wave to the next. Okay, solar wavelengths can be anything from many kilometers to picometers, which are really small. The visible spectrum, okay, this is the part we can see. So most of the solar spectrum is invisible to us. Some of it we can feel as heat, which is infrared. There's a band of waves in the middle of the solar spectrum that we see as visible light. Okay, visible light waves are measured in nanometers, and the colors we see depend on the wavelength. So the length of those waves determines what colors that we see with our eyes. One of your questions was about, how can we see the part that we can see? How is it visible to us? Well, that's the way God made our eyes, okay? He made our eyes to be able to detect certain wavelengths. Okay, so there are also other bands of light, okay? So ultraviolet, infrared, and other bands, okay? Light just outside our ability to see. So the UV range from 10 nanometers to 400 nanometers. These are too short for humans to see. UV rays can cause sunburn. You've heard of these before. It's what you have to be careful for when you stay outside for too long. Infrared waves, these are also known as heat waves. These range from 750 nanometers to, sorry, that's a typo there, 300,000 nanometers, and they are too long to be seen. So the part in between there is what we can actually see. Okay, the sun's color here. Two factors determine it, the intensity of light waves emitted and the sensitivity of our eyes to those colors. Sunlight is most intense in the green, yellow, red region. Our eyes can detect only red, green, and blue light. Our brains combine them and allow us to see other colors. There's a really cool lab that I wanted to do if we were in class that we had to miss this year, where you would put on the glasses and get to see the different colors of light. But for now, we'll just have to read about it. This next one, the sun's composition. So scientists use a spectroscope to learn what the sun is made of. When an element becomes hot enough, it gives off a distinct color. And the sun contains at least 79 of the 92 naturally occurring elements found on Earth, which is really amazing. Hydrogen is the most abundant, and the second is helium. These two make up about 98% of the sun's mass. So the sun is mostly hydrogen and helium. All right, the sun's structure. The interior of the sun, now of course this is based on a model because we cannot get close to the sun because of the heat, but it's based on a model, and it's divided into 3 sections. Okay, the core is the innermost region. This is where nuclear reactions take place and where its energy is generated. This is believed to be about 1/4 of the sun's diameter, and nuclear fusion takes place here, which they discussed on one of those videos that I had you guys watch. Okay, so hydrogen atoms combine under intense heat and pressure and form helium atoms. So it's like one continuous hydrogen bomb going off. It's believed to be about 27 million degrees Fahrenheit, which is much hotter than we can even imagine. All right, the next part of this model is the radiative zone. From the core, concentrated electromagnetic energy moves to this zone. The particles actually don't move very much here compared to in the core. And then the last part is the convective zone. The pressure is low enough in this zone for atoms to move. Hot plasma is replaced by cooler, denser plasma, which creates convection currents, which is why it's called the convective zone. Okay, the surface. The surface of the sun is known as the photosphere. And the temperature is between 8,700 and 10,800 degrees Fahrenheit. It's fluid. It looks like a pot of boiling water, which you saw in the video that you watched. It has granules, which are mounds of hot plasma rising from the interior. And this is where sunspots and solar flares are found, which we'll talk about more in a little bit. Okay, the atmosphere. This extends into space. Plasma particles that the sun's gravity cannot hold. And this has 2 parts. The first is the chromosphere. It's thin. It's 1.3 million degrees Fahrenheit. This has spicules, which are pointed masses of hot plasma that leap 6,000 miles from the surface. And it has how certain layers of our atmosphere help protect us from the solar wind. And this extends as much as 3 times the radius of the solar system. All right, here's a diagram for you so that you can see all the different parts. There's also one in your book that you can look at if you need to see it. Okay, and then this last part for this section here, the sun's activity. Okay, so sunspots, these are small dark areas on the surface. And they're cooler areas within the photosphere, which again is the visible surface of the sun. These last from a few hours all the way to a few months. So that's a huge span that they can have. The same diameter as the Earth, so that's pretty big. They often occur in pairs because of magnetic disturbances. So the sunspot cycle we're going to talk about here. The solar maximum, this is when the sunspots reach a peak, which happens about every 11 years. And then the solar minimum is when the fewest sunspots are there. This affects the Earth's climate. During the active periods, the likelihood of damaging solar flares increase, and it also causes UV changes. These move across the sun's disk, and they disappear at the western limb, and it will reappear at the eastern limb in about 2 weeks. Okay. Here's a picture here so that you can see one. But again, I'm really hoping that you watched the videos that I posted for you that kind of show these in action. Okay, and this last one here that we're going to talk about is the solar flare. This is an explosion of the sun's matter. It emits rays and particles. The magnetic fields associated with sunspots come together, and they destroy each other. If enough of the sun's surface is involved, a large mass of particles blows outward, and that's called a coronal mass ejection, a CME, which was also shown to you on the video. Radiation can disrupt radio communications and damage satellites and power grids. These are extremely powerful and can do a ton of damage. Astronauts on the space station go to a special room to avoid radiation sickness if solar flares occur. Okay, this link here, I'll try to post these slides on the class wall too so you can see them. And if you go to these slides and you click on this link, it just shows you footage of a solar flare so that you can go and watch that if you want to. I'm going to stop there for now. If you have any questions, please let me know. And I hope you all do great on your quiz.